For decades, the moon known as Europa has been hiding a secret right in front of our eyes. To the casual observer, it looked like nothing more than a frozen wasteland, a smooth, silent ball of ice drifting in the cold shadow of Jupiter. Scientists spoke about it with polite interest, but it was rarely the star of the show. We saw a cracked shell, beautiful in photos, yet seemingly unremarkable. But beneath that sterile white surface, something incredible is happening. Something warm. Something active. Something that, by all laws of space, has no business existing so far from the warmth of the sun. In the last 18 months, the James Webb Space Telescope, JWST, has done what no other instrument could. It didn't just take pictures, it pulled back the curtain on Europa's true nature. What it discovered has shattered our old theories. To understand the magnitude of this discovery, we have to look at the cracks in our previous knowledge. Europa is one of the 4 Galilean moons, first spotted by Galileo Galilei in 1610. It's a bit smaller than our own moon, roughly 3,100 kilometers across, and from a distance, it resembles a shattered egg. Its surface is a maze of reddish-brown ridges and streaks that span thousands of kilometers across a global ice sheet. Since the late 1990s, thanks to NASA's Galileo spacecraft, we've suspected that this ice isn't solid all the way through. Magnetic field disruptions near the moon suggested a massive body of conductive liquid, a saltwater ocean, hidden beneath the crust. We're talking about an ocean that likely holds more water than all of Earth's oceans combined, sealed under an ice shell that could be 10 to 30 kilometers thick. This potential for liquid water turned Europa into a celestial celebrity. Where there is water, there is the possibility of life. For 20 years, that was just a dream. We were like children pressing our faces against a frosted window, unable to see what was happening inside. James Webb changed the game. It didn't land a probe or drill a hole, but it used its hypersensitive infrared eyes to read the chemical fingerprints of the surface from 600 million kilometers away. In late 2023, 2 research teams used Webb's near-infrared spectrograph to hunt for a specific prize, carbon dioxide, CO_2. Carbon isn't just another element, it is the fundamental building block of all life on Earth. Finding it on Europa would mean the difference between a dead rock and a living world. The results were stunning. They found high concentrations of carbon dioxide in a region called Terra Regio, a geologically young area where the ice appears disrupted and chaotic. This wasn't just dust from space or meteorites, the distribution showed that the carbon was coming from within. It was seeping up from the dark ocean below, like a stain rising through a white cloth. Geronimo Villanueva from NASA's Goddard Space Flight Center confirmed that this carbon is consistent with an internal origin. We now know that Europa's hidden ocean contains the very chemistry required for biology. But Webb's journey didn't stop there. In early 2024, scientists turned the telescope toward Europa again, searching for plumes, giant geysers of water vapor erupting into space. While the Hubble telescope had hinted at these in the past, Webb's data showed no large, constant eruptions during its observation. This tells us that Europa isn't like Saturn's moon Enceladus, which sprays water continuously. Instead, Europa is shy. Its eruptions are likely sporadic, triggered only when Jupiter's massive gravity flexes the moon at specific points in its elliptical orbit. This brings us to the most fascinating question. How does a moon so far from the sun stay warm enough to host a liquid ocean? The surface temperature is a lethal -160 degrees Celsius. The secret is tidal heating. Jupiter's immense gravitational pull, combined with the tugging of nearby moons Io and Ganymede, stretches and squeezes Europa's core like a rubber ball. This constant friction generates heat. Imagine a rubber ball being squeezed rapidly in your hands. It gets hot. Now imagine that ball is a 3,100 kilometers wide moon being squeezed by the largest planet in our solar system. That energy is what prevents the ocean from freezing solid and likely fuels hydrothermal vents on the seafloor, the exact environment where life is thought to have started on Earth 4 billion years ago. Europa's ocean is estimated to be between 60 and 150 kilometers deep. To put that in perspective, the deepest part of Earth's ocean, the Mariana Trench, is only 11 kilometers deep. Europa's ocean is a leviathan, hidden in a moon smaller than ours. And at the very bottom lies a rocky silicate floor. This contact between liquid water and rock is crucial. It's where minerals dissolve and where the spark of chemistry begins. However, we must be scientifically cautious. Finding carbon dioxide isn't the same as finding a swimming alien. The jump from habitable conditions to actual life is a massive one. But what Webb has done is eliminate the ifs. We knew there was water, we knew there was energy, now we know there is carbon. The ingredients are all on the table. This leads us to the next chapter, NASA's Europa Clipper mission. Launched in October 2024, Clipper is the most sophisticated probe ever sent to the outer solar system. It will perform 50 close flybys, some as low as 25 kilometers above the ice. Clipper's mission is to taste the material Webb identified. Its SUDA instrument, Surface Dust Analyzer, will catch microscopic grains of ice kicked up from the surface and analyze them for organic molecules. If Terra Regio is truly a gateway to the ocean, Clipper will find out. But Clipper has to survive a nightmare environment. Jupiter's radiation belts are so intense they could kill an unshielded human in hours. The spacecraft's electronics are protected inside a thick titanium vault, and it must dip into the radiation zone and quickly retreat to survive. One of its most exciting tools is Reason, an ice-penetrating radar designed to look 30 kilometers deep. It might find great lakes of liquid water trapped within the ice shell itself, pockets of life-sustaining water much closer to the surface than the deep ocean. There is also a dark side to this moon. Jupiter's radiation, while lethal, might actually be feeding the ocean. The radiation breaks apart surface ice molecules, creating oxygen. This oxygen could be sucked down through cracks in the ice into the ocean, acting as a chemical food source for any organisms below. It's a strange, beautiful irony. The very radiation that sterilizes the surface might be the breath of life for the ocean below. As we move toward 2030, the year Clipper arrives at Jupiter, the stakes have never been higher. For the first time in human history, the question of alien life has moved from the realm of philosophy to the realm of chemistry. We aren't just wondering if anymore, we are looking at a specific map with an X marked on Terra Regio. If we ever manage to land on that fractured ice, melt through the crust, and lower a camera into that dark, ancient water, what will we see? Whether it's a barren saltwater desert or a world teeming with strange life, the answer will change our place in the universe forever. We will finally know if the spark of life is a universal constant or a lonely miracle. For now, we wait and watch. Because for the first time, we aren't just waiting with hope, we are waiting with evidence.